Bonsoir et bienvenue au laboratoire de la Gaîté Lyrique, notre observatoire critique des technologies. Welcome everybody. I will start by saying a few words in French before switching in English, so sorry for repeating myself. I'm Marie Lechner, I'm a programmer here at Gaîté Lyrique, and I will switch right now in French. Donc, cette rencontre du laboratoire se déroule dans le cadre d'un programme en ligne de la Gaîté Lyrique Plein Écran. Et c'est la quatrième et dernière d'une série intitulée « Dansez maintenant », qui était un ensemble de conférences, de performances et de tables rondes conçues avec les artistes Julien Prévieux et Jeff Guess, qui s'est penché sur notre frénésie à tout quantifier, à tout traduire en nombre. Et on voulait essayer de voir ce qui se jouait justement dans ce mouvement de réduction de nos paroles, nos gestes, nos émotions à des chiffres. Donc, lors des précédentes rencontres, on s'était penché sur cette vie quantifiée, sur la manière dont nos corps étaient de plus en plus intimement scrutés par des dispositifs de traçage et de surveillance multiples, à l'ère des technologies d'apprentissage automatique de plus en plus sophistiquées. Vous pouvez retrouver ces différentes séances en ligne, je vous mettrai le lien dans le chat. Et aujourd'hui, nous allons nous intéresser à la manière dont ces technologies ne font pas que transcrire et interpréter le réel, mais comment elles le génèrent et littéralement l'hallucinent. Donc, le point de départ de cette réflexion est un article paru en août 2018 qui s'intitulait « Everybody Dance Now », où des chercheurs californiens ont montré comment des algorithmes d'apprentissage profond permettaient de transférer les mouvements d'un danseur professionnel sur le corps d'un danseur amateur. Donc, cette performance a été rendue possible par les GAN, ou réseaux antagonistes génératifs, qui est une technique de machine learning qui permet de générer, entre autres, des visages et des corps de synthèse photoréalistes qui n'existent pas et qui commencent à proliférer sur Internet, et qu'on désigne souvent dans le langage courant sous le nom de deepfake. Donc ce soir, on va vous proposer deux interventions. Donc ça va être une séance entièrement en anglais. La première de Fabian Offert, qui est professeur assistant en histoire et théorie des humanités numériques à l'Université de Californie à Santa Barbara, et dont l'intervention est intitulée « Hallucinating Bodies, Gains Between Science and Fiction », et qui sera suivie d'une conférence de Francis Unger, qui est artiste et chercheur basé à Leipzig, et qui est intitulée « Elle, Unhype AI », et qui va notamment s'intéresser aux tactiques comment répondre, comment parasiter en fait ces systèmes. So now I switch in English, and sorry for repeating myself again. So this meeting takes place within the framework of the online program of the Gaîté Lyrique called Plein Écran, full screen. It is the fourth and last in a series entitled dansez maintenant, Let's Dance Now, conceived with the artists Julien Prévieux and Jeff Guess, which examined our frenzy to quantify everything, to translate everything into numbers, and what is at stake in this movement to reduce our words, our gesture, our emotion to numbers. So in previous meetings, we were looking at quantified life and how our body are increasingly scrutinized by multiple tracking and surveillance devices in an era of increasing sophisticated machine learning technologies. So, and today we are going to look at how this technology not only transcribe and interpret reality, but also how they generate it. And maybe I will first give a short presentation of Fabian Offert, who is assistant professor of history and theory of digital humanities at the University of California at Santa Barbara. And he will talk about GANs. So the title is Hallucinating Bodies, GANs Between Science and Fiction. And Generative adversarial networks, as Fabian will explain, are not only the core technology in deepfakes and other disinformation tactics, but also increasingly used to solve all kinds of image reconstruction problems in the sciences. So in this talk, Fabian will look at some of the fundamental epistemological problems resulting from this omnipresence of GANs and attempt to delineate the peculiar position between science and fiction. And before joining the faculty at Santa Barbara, Fabian was also postdoctoral researcher in the research project, Synthetic Images as a Mean of Knowledge Production at Friedrich Alexander University, Erlangen, and affiliated researcher in the Artificial Intelligence and Media Philosophy Research Group at Karlsruhe University of Art and Design. And please, Fabian, the mic is yours, and I will introduce Francis right after.
Okay, great. I hope everybody can hear me. Thank you so much, Marie, for the generous introduction. Thank you for hosting this incredible series, which is really great. I'm really happy to be here. I wish I could be in Paris. This was actually the first thing was canceled for me, so I'm happy that we're kind of repeating it, even if it is only virtually for now. So my talk today is called Hallucinating Bodies, GANs between science and fiction. And what I would like to talk about are some of the fundamental epistemological challenges that result from the existence of these people here that surround me, but rather from the existence of a machine learning architecture called Generative Adversarial Network, or GAN for short, as Marie already mentioned. Because of course, and if you read the description for today's event, you know these people here are not real. They were generated by a GAN, more specifically by an architecture called StyleGAN2, short for Style-Based Generative Adversarial Network 2, obviously, that was trained on a very large data set of photos scraped from the website Flickr, which is a photo sharing website. And if you want, you can make your own imaginary people. You just go to a neat little website on the internet called thispersondoesnotexist.com, and this will let you generate an infinite number of these photos, like this guy here on the left, for instance. And you can see how real these photos look, right? And in fact, for some of them, we would need another machine learning system to reliably identify them as imaginary, as fake images. But what I would like to argue for today is that the implications of this technology go much deeper, actually, than we would assume from these and other fun examples that you can find all across the internet. GANs in 2021, I would say, are everything but tech demos. In fact, if we talk about GANs hallucinating bodies, we have to talk about all kinds of bodies, from human bodies, both inside and out, as it turns out, to celestial bodies light years away. GANs, we could say, have become their own trading zone, connecting disciplines and methodologies from astronomy to medicine. This also means I will not talk about face recognition or about deepfakes or about any of these topics today, not because I think these issues deserve no attention. In fact, I've been vocally arguing for a total face recognition ban for several years now, but because I feel that some of the less obvious but potentially even more problematic issues of GANs are unfolding beyond the current scope of research in media studies, critical AI studies, and related disciplines. And we run the risk of losing track of them. So let's start with a brief look into the technical specificity of GANs, of generative adversarial networks. Generative adversarial networks are a specific kind of deep convolutional neural network, which in turn is a specific kind of artificial neural network. And while I talk about this, we will watch Yann Lequin, who is now head of AI research at Facebook, present such a convolutional neural network recognizing handwritten digits. And this is a demo from the year 1993. So this is one of the first demonstrated use cases of these systems. And I like this video a lot because you'll see that at the end, everybody is like really happy that this is finally working. So watch out for the end of this. So artificial neural networks learn from large amounts of data. That means in the case of images, they look at, you could say, all the images in a data set and attempt to model the probability distribution that is inherent to the data set that best represents the images in the data set. Why does this work? Well, in theory, artificial neural networks can learn arbitrary functions. That means they can also learn the likely very complicated and thus almost impossible to hand engineer function that defines a set of images, which for the machine are just basically large three-dimensional matrices. And by the way, this is a major theoretical result, the fact that neural networks are universal approximators, universal function approximators. That has been around much longer than the current AI hype. So actually, this was first proposed in 1989 by Kotornik. But importantly, human faces, if we neatly align them for the camera, are actually the best possible data for such a system to learn. They are reasonably symmetric and usually have the same very distinct identifiable parts. This is also why face recognition works so well, probably better than any other AI technology today. Faces are easily compressible into just a few directions of change, as we could say, or a few principal components, as computer scientists would call them. This is also why some image sources are better suited to GAN training than others. If you've ever been to ZKM, which is the big media art museum in Karlsruhe in Germany, you've probably seen this work called Flick.ka. This was a photo booth that the ZKM put into their lobby, actually, starting in 2007, and people could take photos there, and then they had some sort of screen in the exhibition space that would occasionally browse through all this visitor photos. So this was obviously in 2007 before, major concerns about privacy and data protection. And in 2019, Daniel Heiss made an artwork out of this resource, out of this photo data set. And on the left, you see the GAN interpolating between different points in latent space. So basically coming up with new imaginary people on the basis of this data set from Flick.ka. And in the exhibition in 2019, they also had this kind of like spot the difference game where you were asked to identify generated from born, as they called it, images in the exhibition space. Here is another work that I quite like and that you might have seen already that shows that this does not only work with faces, but of course also with other data that is more or less neatly aligned. This is Anna Ridler's Myriad Tulips, where she painfully put together a hand-curated, hand-photographed data set of tulips and then trained a GAN to generate new varieties of tulips, which she exhibited in the exhibition space. But how do GANs model these heavily aligned data sets exactly? So technically, GANs define a continuous noise distribution, which we could call Z, which is mapped to a discrete data space. We could also say to image space via G, and G is a generator network, an inverted deep convolutional neural network that expands an input data, an input variable into an image, rather than compressing an image into a classification probability. This generator, G, is trained in conjunction with a discriminator, a second deep convolutional neural network, that outputs a single scalar, which represents the probability that an image came from the training data rather than from the generator G. So less technically, the generator G learns to transform any high-dimensional latent vector, Z, into an image, while the discriminator learns to distinguish such artificially created images from a set of real images that it is provided by the user or by the developer. And the important part here is the generator has no access to these real images, right? It just learns from the feedback that it gets from the discriminator. And this means that the generator cannot just memorize the data set. It has to come up with its own variations. The analogy that people often use to describe this process is that of an art forger and an art historian. So the art forger would, continually create new fake artworks, and the art historian would be tasked with identifying if an artwork is an actual fake made by the art forger, or if it is part of a set of real artworks in kind of continuous loop. What's important here is that at every iteration of the GAN training process, an image is created and then destroyed. And it's this oscillation that lies at the core of the fundamental epistemological problems of GANs. Because, as Peter Galison famously reminds us, we desperately need images to make sense of the world. But at the same time, we also fall so easily for what Galison calls siren call of material specificity. As objects in the world, their simple presence, the simple presence of images, often obfuscates their inadequacy as vehicles of representation. At the same time, we cannot proceed further towards abstraction, as Galison writes, without images, simply because we cannot think in purely symbolic operations. So the image in general oscillates. It is unstable and subject to forces that pull it in either direction. The image wants, to invoke W.J.T. Mitchell here, to be something it is not. It wants to be either a symbolic description or a purely material object without any representational obligations. And the fact that this specific image here has been acquired by the Museum of Modern Art, New York, speaks of this as part of a collection. The image's desires here are finally fulfilled. So this epistemic oscillation generally concerns both analog and digital images, but for Galison at least, the computer has rendered the flickering exchanges, as he writes, between the abstract and the pictorial more or less routine. The computer enables images to easily scatter into data, as he says, or data to gather into images. And the famous black hole photo here from 2019 is a good example for this dilemma. The image's only raison d'etre is to give evidence to the symbolic equations that describe the phenomenon it represents. It exists on the threshold to the non-image as a last glimpse of what is pictorially possible. My point is, in GANs, this inherent oscillation of digital images, right? So images being kind of like torn between their representational obligations of representing something and being a material object that is an object in the world. In GANs, this is infinitely amplified. At every iteration of the GAN training process, an image is created from data and destroyed into data. Data gather into images, images scatter into data. This epistemic oscillation of digital images is thus the defining feature of generative adversarial networks of GANs. Admittedly, this is a rather, let's say, theoretical result here, right? But we should keep this in mind moving on to one of the most central interdisciplinary applications of GANs that I would like to talk about today, which is the problem of super resolution. So very briefly, what is super resolution? Super resolution is a set of problems, and a corresponding set of computational methods, revolving around the fact that finite resolution images can only reproduce finite details. So as a great artistic example, this is Chuck Close's work, Bob, from 1970, where he extracts as much detail as he can, as possible, from a quite small photograph using this very established raster method. So here it is in its full glory. So it's really, really large compared to the original photograph. That's the whole point of this work. But this is, of course, a quite analog process. So what happens in the digital realm? What happens with digital images? So in the digital realm, the limit of such an interpolation is actually quite precisely defined as the Shannon-Nyquist limit, also called the deconvolution limit. Simply put, we cannot extract more information from an image than we have in the image. That's the very simple essence of the Shannon-Nyquist limit. But why would we even want that? Why would we even try that? Well, it turns out there are many scenarios where such a method would come in handy. And the most famous one is, of course, the whole enhanced trope that you know from the X-Files. This is my example here on the left. And other TV shows and movies, most famously Blade Runner. So we have some low resolution surveillance camera footage, like this one here. And we would like to see one little detail. So what we do is we enhance it infinitely. What we see in the video is, of course, impossible. So we cannot reconstruct arbitrary details from blurred, low resolution, or otherwise heavily distorted images. Well, can we? So one way to attempt to go beyond this so-called deconvolution limit is the introduction of additional knowledge about the image that is to be reconstructed. So additional facts that are not in the image, but that we nevertheless somehow have at hand. This could be, for instance, information on the likelihood of certain colors, certain shapes, or certain textures appearing in an image. And it turns out that generative adversarial network scans are very good at producing these priors. So we can use GANs to learn additional facts for us and use these additional facts to transcend the deconvolution limit. But immediately, we are faced with a big problem. The image that we are reconstructing from, so the noisy or pixelated or blurry or low resolution image, technically has less information than the image that we are reconstructing. So there are, of course, multiple possible solutions to a reconstruction problem, right? You can reconstruct different versions of a high-resolution image from a low-resolution image. Now, which of these multiple solutions gets picked if we are using GANs depends exactly and only on the additional facts learned by our GAN. But unfortunately for us, unlike in Chuck Close's drawing, we cannot rely on any aesthetic faculty or embodied experience in building these additional facts. They are only based on the images that the GAN has seen. In the more or less viral example on the bottom right, for instance, a super resolution GAN proposed an image of a random white guy as the go-to solution for the reconstruction of a photo that is, we can all see it is clearly a pixelated Obama. This is, of course, an artifact of a heavily biased data set, and you can imagine the justified backlash that this particular demo caused. But here's the thing about this example. We as humans can immediately see that this solution is not correct, yet here's our GAN proudly presenting it to us. In other words, GANs do not fail. They do not break down. They will always give us something, right? They will always produce an image, a solution that might or might not be what we are actually looking for. And on top of that, there are no mechanisms to catch incorrect solutions other than relying on our own additional knowledge about the problem domain. That means even in cases where there is obviously no solution to a reconstruction problem, no solution at all, the GAN will still happily provide us one. On the right, this is the main character from the computer game Doom, a pretty famous game. It's also quite old and limited to a 320 by 200 maximum resolution. So this is what people have called an 8-bit game. That also means there simply is no high resolution version of the main character or of any of the other characters for that matter. So this is a problem that has no solution, but that is nevertheless solved by the GAN if we let it. And it's here, I think, that the speculative nature of GANs becomes glaringly obvious. And it's exactly this speculative nature that I think also makes GANs so appealing as artistic tools. But as I mentioned in the beginning, GANs are not only used as artistic tools. In fact, one of the most important problems in astronomy, for instance, is the reconstruction of images that have been perturbed by noise produced by the very instruments that facilitate the imaging. What does that mean? That means advanced telescopes, for instance, enable the observation of previously unknown astronomical objects, but these observations are subject to specific noise that is introduced by advanced telescopes only, so by the very medium that is used to observe. So we need to find a way, or rather astronomers need to find a way, to disentangle these two signals. And as it is the case with super resolution, traditional signal processing tells us that there is an empirical limit, the deconvolution limit, that we cannot transcend. But again, with GANs, it looks like we can transcend this limit. So this image that you see here is from a recent paper, and it shows a comparison of a GAN-based denoising algorithm with a traditional state-of-the-art denoising algorithm that doesn't use machine learning. And so the GAN is the second from the right, and you can immediately see that the GAN produces much, much better results, right? The image really subjectively looks much better. But again, we have no way of verifying these solutions. And now, other than in the phase super resolution example, we are also dealing with objects that are light years away. So our current state of knowledge about these celestial bodies is likely limited anyway. But because we're using GANs, we are now declaring our current state of knowledge the maximum attainable state of knowledge. So GANs, in a peculiar way, operationalize the epistemological distinction between invention and discovery by rendering the space of discovery a technically determined space. And this determination is a historical determination. Where GANs serve as a medium, where GANs are used, where GANs are employed, what there is to know is what is already known. So looking at galaxies with neural networks is looking into neural networks exclusively. Now, just to backtrack a tiny bit here, of course, any optical medium influences the space of discovery that it facilitates, right? This is what optical media do. If you ask Friedrich Kittler, for instance, or many other people. So using a telescope obviously opens up a different space of discovery than if you would observe the sky with the naked eye. Famously, when Galileo invented the telescope, he was allegedly immediately skeptical that it would distort the truth somehow. The point is, though, with GANs, the space of discovery is not constrained like it is with other media, but it is completely replaced. Every single pixel in the input image is replaced with a pixel from the GAN latent space. Even if it's the same pixel, it is replaced. So neural network vision is not augmented reality, it is really virtual reality. Everything is replaced. And actually, we do not even have to venture into space to see these implications at work. In fact, we can return to the human bodies we started with, but turn them inside out, because in recent years, GANs have become human-centered. I'm intentionally kind of like misusing the technical term here. And they have found their way into the medical field with, what I would say are really wide-ranging consequences. So in a recent paper called Distribution Matching Losses Can Hallucinate Features in Medical Image Translation, for instance, the authors investigated a system based on cycle GAN. This is a GAN-based approach to unpaired image-to-image translation. So for translating between one kind of image to another kind of image. To put this in context, in medical imaging, image making is obviously complex and expensive. So attempts have been made to employ machine learning to translate between different flavors of MRI images. And here, the figure that you see, people attempt a translation between so-called FLAIR and T1 MRI images. But what the authors of the paper now show is that if the training sets from both domains, so the images that you train the system on, are unbalanced, for instance, if there are too many or too few images of cancerous tissue in one of the data sets, cycle GAN will hallucinate features in the translated image. As the authors state, they, quote, cure cancer in images and cause cancer in images using a cycle GAN that translates between FLAIR and T1 MRI samples. Moreover, in a thorough analysis of the imbalance needed to induce such hallucinations, they show that the imbalance in the data set has not to be total, right? So not only cancerous tissue in one set and only healthy tissue in the other, but there's a lesser threshold where feature different samples become irrelevant to the GAN. Given this and an infinite number of other examples of partly outrageous human-centered applications being constantly proposed in the technical communities, one could rightfully ask if GANs can ever have a place in science at all, if their incredible potential to conceal their absolute dependence on priors is not fundamentally opposed to scientific principles in the first place. And at the end of the day, we could say basically all GAN images are deepfakes. Right? All GAN images are images designed to deceive. And on top of that, as it has recently turned out, GANs actually do memorize certain things after all, and may leak your identity, or as the title of a recent paper puts it, this face does not exist, but it might be yours. One could argue then that the only real benefit of GANs is exactly this speculative nature, their tendency to capture and distort in interesting ways what is already known. And in fact, we can look again, and maybe only, to artistic applications of GANs to see this approach become productive. This is Tigar Brain's recent work, Asunder, and Asunder is a free-channel video installation that I would say speculates on the potentiality of climate interventions. So in the installation, a GAN is used that has learned to generate imaginary satellite images according to certain parameters. Real-life satellite images are changed by this network to suggest radical geoengineering interventions. So removing the city of San Francisco, planting trees in the desert, rerouting rivers, you get the point. The resulting composite image, like this one here, where I think they put a desert right next to what looks to be the East Bay, actually, I think. Such a composite image is then fed into a scientific climate model which runs on a high-performance computer in the exhibition space, and the predicted changes in the global climate are displayed. And I think this work is fascinating exactly because it puts the speculative nature of GANs on its feet. The literal alien perspective of machine learning systems is transformed into a productive alienation in the Brechtian sense, into a way to distance oneself from the technical apparatus and reflect on its socio-technical implications. This is an artistic intervention, of course, but it points, I think, to the incredible critical potential of machine learning systems like GANs, if we learn to tame and put to use their speculative nature, rather than relying on them as truth machines that transcend the natural limits of what can be known. Thank you so much for your attention. If you want to get in touch, you can use these means of communication. Thank you again, and I look forward to your questions, and then to a couple of brief questions, I think, and then after to Francis's talk and our discussion later on. Thank you.
Thank you, Fabian. There was one question in the chat about the sources you mentioned from online coachings. So maybe people can just get in touch with you through your Twitter account to get these sources you mentioned. She was asking the siren reference, for example. Do you hear me, Fabian?
Oh, sorry. I think I didn't hear you. Apologies. Could you repeat that? I think the sound was off on my computer. Sorry about that.
No problem. I was just saying that in the chat, online coaching was asking for the list of sources that if you could share them. And she was especially interested in the siren reference. So maybe also you can just contact Fabian on his Twitter account.
Yeah, I can put the Galison paper maybe in the chat, and then also I have a paper coming out about this topic. So once this is out, I can share it.
And we have yes, also a question by Warren. Do we have attendance code for today's lectures? So, I mean, yeah, I asked, maybe one of your students, no?
That is one of my students who I asked to join. No, actually, you're free to come and go as you like, no attendance. Thank you for asking, though.
So anyway, you can also keep your questions for after Francis talk. Thanks a lot, Fabian, for this really enlightening talk about GANs. And Francis, if you're around, so I will present Francis Unger very shortly. He's a Leipzig-based artist and researcher, and his work can take all sorts of forms of installation, radio plays, performances, and he offers a critical examination of historiography of technology. And he's right now writing a PhD about the concept underlying electronic database technology, if I'm right, yeah. Its historical roots and the associated social and cultural friction. And Francis, in his talk called Unhype AI, we'll discuss how AI needs to be framed differently in the public discourse, and how to provide alternative to the language we use of AI. And he will also give some example on how the statistical models at the heart of machine learning can be actively derailed. And he will present us maybe some examples of how to disrupt this normative regime of neural network used for biometrics, facial recognition, and other user tracking behavior. Francis, the mic is yours.
Okay, I just have to switch to the presentation. Do you see the presentation?
Yes.
Yes, okay. Yeah, so thanks a lot for the invitation to Marie Lechner and to the Gaîté Lyrique. I'm very grateful to be talking today. I'd like to offer a reading that is not inspired by technology and the promises made about it, but it's a critical reading from a humanities perspective. And first, I'll discuss how AI could be framed differently through language. And in the second part of this talk, I'll discuss a few artworks and projects which subvert computer vision in order to show the limitations of automated pattern recognition, as I call it. I will talk about adversarials, but not about generative adversarial networks. But yeah, adversarials are kind of the same technique, but somewhat different. And we will see how it plays out. The talk will be around 35 to 40 minutes, so stay with me. Let's first talk a little bit about hype. The researcher Ramon Amaro argues there is an audacity of hype, framing AI as new when indeed it has a genealogy towards data, statistics, and the quantifiable, which already exists for a long time, reaching at least back to the 18th century. Hype allows us to distance ourselves from the social, the human, and the human processes. Hype is a deception to use technology as the other, and in this case, the AI or the algorithm is kind of the other. And hype also builds on the complicity of the audiences who agree to be misled. So discussions around AI, be it affirmative or critical, sometimes sound just as if the participants would visit a magician's show. They want to believe in the magic abilities, and in a way, I'm arguing this is how Zizek would describe the function of ideology, that both the critics and the affirmative users are perpetuating it. So how do we recognize that we deal with AI hype? So first of all, AI hype does not question if a certain task is actually needed at all. It also does not question if it is needed to be solved by AI. So we have a lot of AI nonsense. Quite a few problems already have been solved in the computer space, but now what you need to do is when you when you try to sell it, you call it AI. And the second point, how to detect AI hype, is these misleading promises such as AI will end poverty. So ending poverty actually is a wicked problem. AI can help to solve a proxy, like it can help to deliver statistics or detect certain patterns that correlate with poverty, but correlation is not causation. Neither can AI actively end poverty, nor can it express the causes of an issue. Okay. AI in the public discourse is framed in a specific way in order to appear necessary, unavoidable, and overwhelming. And what I want to do today is to reframe it. I will do so using two approaches. I will discuss the language which we use for AI and try to provide alternatives. And second, we will look at examples how to actively derail AI and subvert software, which is called AI software. And let me first talk about terminology. So imagine the headline, "Can statistics be creative?" Like, this would be the actual headline of "Can AI be creative?" So, well, that's of course much more boring, so nobody will use it. Statistics, ugh. So I wrapped my head around it, how to change the common notions. And I'm not saying this is a comprehensive or fully developed proposal, but yeah, I just tried to come up with something. So an alternative terminology could look like that. We would translate artificial intelligence towards automated pattern recognition or just pattern recognition. although I have to add that's not completely true. But yeah, let's see. Then machine learning could be machine conditioning or automated classification. The neural network could be a weighted network. Deep learning would translate to deep conditioning, and the neuron would translate to weight or node. This approach comes with its own problems, but it's maybe the best approach that I can deliver today. So let me talk first a little bit more about intelligence. Artificial intelligence, l'intelligence artificielle. The word intelligence takes different meanings in different languages. In French and also in German, it has the main meaning of understanding, prudence, conception, and comprehension. In American English and in English, it's more or less the same. It's prudence, conception, and comprehension, but it is also reconnaissance, intelligence information, and news, like in the Central Intelligence Agency. So I think the American meaning stresses the reconnaissance aspect much more, and it gets kind of intentionally mistranslated into French or German already. And generally, we can see now how already using the word intelligence poses a problem. Historically, the term artificial intelligence was coined by John McCarthy and Marvin Minsky in the 1970s. And it was part of a development that was contradictory to today's weighted network approaches. This development at that time, they were looking into creating symbolic and logical relations in AI, which is not what we are having today. So from there, the term, which originally was intended to oppose the weights and the cybernetic approach, lived on and is now in use. One way to solve this tension would be to not talk about intelligence, and not about cognition, but about recognition. And it's a specific recognition, it's pattern recognition. So cognition would be an active thing, an active understanding, but recognition already has a certain passivity built into it. And that's what I'm aiming for making clear that we deal with machines and that it is humans who set these machines in motion, even when we form, in the end, human-machine assemblages. So we de-anthropomorphize the term by introducing a hierarchy, a human-machine hierarchy, where clearly it was the human who set the thing in motion. Let me talk a bit about learning. So the 1957 Perceptron paper by Frank Rosenblatt insists that machines can learn. And I'm quoting from it, quote, "Recent theoretical studies by this writer, Rosenblatt, indicate that it should be feasible to construct an electronic or electromechanical system which will learn to recognize similarities or identities between patterns of optical, electrical, or tonal information in a manner which may be closely analogous to the perceptual process of the biological brain." It is remarkable that Rosenblatt talks of patterns here, so my idea of using the notion of pattern recognition instead of AI might have its historical roots. Yet we also see that a lot of today's terminology is rooted in 1970s cybernetics. I'm correcting myself, in 1960s inspired cybernetics papers already. So they assumed that the human brain was working like a computer. So they just introduced the idea that a machine could learn, which resulted in the term machine learning, where obviously machines do not learn anything, and we do not actually teach them, although this term teaching is being used quite a lot in this context. Today in machine learning, the learning methods could be described as finding the best model within a space of statistical hypotheses, automatically generated by the algorithm. but that particular meaning of learning is anthropomorphizing an optimization process. So I really think language should be changed here, simply because learning in its narrow sense involves acts of comprehension and causation. And that's exactly what these software machines don't do. It is remarkable that, let me talk a little bit about the conditioning and classification thing. So the process of conditioning a network by a human consists of letting an algorithm, through backpropagation, modify the weights of each node in order to tell the nodes whether it should let a signal pass to the next layer and to which nodes in the next layer the signal shall be passed. Instead of using learning, I would like to use the notion of conditioning as in the Pavlovian reflex, in which a potent stimulus is paired with a previously neutral stimulus. And I'm suggesting that the process of backpropagation, which adjusts the weights in the weighted networks, has its similarities to the conditioning or training of a Pavlovian dog. The dog doesn't know why it is doing something, it just does it. So, and the same with the weighted network. It doesn't know why it's doing something, it just does it. The humans who observe, train, or condition the network actually know why a result is deemed true or false. So the cognitive agency is with them, not with the network. And I will show later an example of a classification task. Classification, for instance, object detection, is the most frequent application of AI embedded in everyday software. So I think it would really help to change machine learning to machine conditioning or to automated classification. Shortly about the neuron. If we agree that brains are not a computer, we might want to change the language that's being used there as well. So my argument refers to the embodiment of human thinking. The promise of the term computer brain is that there would be thinking machines functioning like a brain, and that the brain is the only thing in humans that think. However, human thinking is not just shaped by abstractions, but also by embodiment, for instance, by high blood pressure or anxieties. Thinking is shaped by domain awareness, by reacting to context, for instance, a thought on a street compared to the same thought in a room while listening to specific music. Or the context of thinking also includes friendship. With whom do I exchange ideas? And finally, desire. Having had a fight with my lover, then the thinking might be shaped by that. I might have much more negative feelings, and maybe I'm gonna just develop a very different thought from when I would kind of be emotionally leveled. So this all influences thinking, and without these embodiments and context, I wouldn't call a process thinking or cognition. So I suggest that a neuron becomes a node or a weight, and a convoluted neural network would become a convoluted weighted network. And this would be, in my opinion, much more honest. Sorry, I have to stick to the black slide. A few words about the use of verbs. Andreas Bruckmann recently in an email exchange criticized how, and I'm quoting, the technical system sees, it learns, it deals with, and I would extend this with verbs like it creates or it produces. And Bruckmann also reminds us that these verbs are often connected with concepts like meaning, image, machine, and I would also add things like art or creativity. A question like, can AI create art, can be simply answered with no, but the hype produces countless news articles of this kind anyway. So it is, however, important to acknowledge that, first of all, the use of active verbs like AI does this and that, perpetuates a reading of AI, not as a technosocial system, but as a consciously acting entity. And also the use of subjects which AI supposedly acts on identifies separate knowledge domains which have been formalized through human labor in advance. So before they could be computed by pattern recognition, humans have done the formalization. So no magic here, just human labor. And to illustrate that, take a sentence like, I'm quoting here, the most impressive cases are where AI is pushing us up as humans into the new. And it is obvious that it is not the AI that is pushing us, but it is the humans who set an algorithmic figuration in motion. And this could be easily reformulated towards the most impressive cases are where humans are pushing us into the new using pattern recognition or using statistics. So this is how a dehyped language would sound like. So compared to the 1950s, today we know that the human brain is not a computer, and our understanding has shifted since then. And I think so can our language. So this has been the first part of my talk, and now I'm gonna come up with a few examples to underline that. In the following section, I'm looking into artistic projects and also into scientific research that have tested practices and subverted pattern recognition, machine conditioning, and weighted networks. And the first project that I want to come up with is by James Bridle. It's called Autonomous Trap. In his 2017 work, Autonomous Trap, artist James Bridle used ritual magic against the backdrop of Mount Parnassus in central Greece, the place of the Oracle of Delphi. He created a magic salt circle of road markings that could help trap an autonomous car by letting it in, but not letting it out. This example is based on his own approaches to build an autonomous car using pattern recognition together with technology such as a LiDAR, that's a light detection and ranging sensor, and video sensors. This method could be called trap iconography. So trap iconography is any intentionally installed, painted, or otherwise applied sign or a graphic which surprises and disorients weighted networks. This approach could also be used against delivery robots or lawnmower robots. Yeah, so there's actually broad potential. And a recent case just shows that autonomous trap is not just an artist's assumption. In Somerset County, this installation of a cattle grid, according to news reports, had to be taken away because braking assistance systems in cars regularly mistook it for a wall and initiated emergency braking at that point at the street. Simon Weckert, the Google Maps traffic jam. So this next method is a traffic-related, and I call it data poison. Artist Simon Weckert generates poison data by transporting 99 second-hand smartphones in a handcart and generates a virtual traffic jam in Google Maps. Through this activity, he shows that it is possible to turn a green street in Google Maps red. This in turn has an impact in the physical world. Car owners observing the red signature on the map may choose another route to avoid being stuck in traffic. It's a great way to show how weighted networks interpret live data according to the already established weights without even understanding that the density of about 100 phones per square meter doesn't make any sense, so it should be just ignored. A less poetic version of data poisoning was tested in 2018 against deep weighted networks by a group of scientists and published in a scientific paper by Eichhold et al. Called Robust Physical World Attacks on Deep Learning Models. So they applied these black and white stickers to an actual road sign, a stop sign, causing a 100% recognition failure under lab conditions and 85 failure recording video in a field test while driving a car. So the researchers were originally using the GTSRB convolutional weighted network that is trained on the German traffic sign recognition benchmark, and also the Inception version 3 convolutional weighted network. This was in 2018, or that's when the paper came out, so probably it was 2017 maybe. And I have tested these images of the stop sign with Google Vision API in 2021, and it actually recognizes the stop sign with a 95% probability. So we see how some attacks are not valid anymore 4 years later, following the development from Inception version 3 to today's ResNet, which is used by Google. So whether this real-world test just shows that the system used for autonomous cars need improvement, or that autonomous cars won't exist within their own complete support infrastructure, is up to discussion. A less poetic version of data poisoning was tested in 2018 against deep weighted networks by a group of scientists and published in a scientific paper by Eichhold et al. And they applied, sorry, I'm reading the same text again, sorry. I have to, okay. So another research team, Chen et al. In 2018 has taken this approach even further and produced beautiful perturbation street signs which identify as a person or sports wall to a convolution-weighted network. They have used a Canon photo printer and tested it out on the streets. I'm quoting from their paper. This attack is significant because the attacker does not need to know what image they are attacking when constructing the attack. After generating an adversarial patch, the patch could be widely distributed across the internet for other attackers to print out and use. So the same kind of attack has been used by these two guys from Belgium. They have used an adversarial patch to fool a detector for moving images detection called YOLO2. And so we see on the left, the person is recognized as a person. On the right, the person having this adversarial patch is just not recognized by the network. And they have, for quite some time, been trying around with different shapes and patterns and sizes until they came up with these two, for instance, and there are many more versions of it. Yeah, so the one more project that I want to talk about is a project that I was involved myself in together with the hacker Flupke. It's called adversarial.io. We have created this kind of web page or web service. Please don't go immediately there because it's going to break down if more than 2 people at the same time access it. I mean, not the website, but the web service at the back end. So it takes a picture, you can upload a picture, and then based on the Google Inception version 3 convoluted weighted network, it classifies the picture and then subsequently moves the detection onwards to the next class by adding extra pixels to it. And humans will recognize possibly the resulting pictures, and machines will also recognize it, but falsely. So when a picture is processed through a convoluted weighted network, the complicated mathematical calculations boil down to a single number in the end, which is an ID number. And this ID number identifies classes in a list. And we see it here. So the ID number 323, it contains then the class monarch, monarch butterfly, and so on. So if you manage to change the ID number, you change the associated class and description of the image. Google Inception version 3 is an older example with only 1,000 classes. Today's networks and classes are more fine-grained, but the principle, it remains. Why does the noise pattern then look the way that it looks? Well, they are basically visual representations of mathematical functions. The parameters of these mathematical functions have been tweaked to specific values which allow the function to express a certain directedness in the mathematical vector space. And this directedness makes the convoluted weighted network jump on it, since it delivers the closest mathematical solution to a given problem. The adversarial in total makes the model to jump not to the class where it should go to, monarch, but to a different class, for instance, tray. And the added pixel changed the gradient slightly and kind of helped to push the weights just a tiny bit towards the next iterative class during the conditioning process. So what we do is we extrapolate. It means we change the intensity of pixels to move it outside of their original scope. Adversarial I/O is not just a hack, but also an educational project, since we collect various adversarials in the blog and try to dig out complicated research on that topic. It's running on cheap infrastructure and can potentially be repeated by third parties. And basically my hope is that at one point, this technique becomes standard in any kind of cameras or phones. So whenever you take a picture, you get the option to possibly already embed the adversarial in it. And I have skipped 2 examples. I'm going to continue with the Cow-Tuner. So the Cow-Tuner in itself demonstrates that recent convolutional weighted networks prefer texture over shape. The mountains, as a context, move this adversarial nonsense towards nowhere. So the real answer for this kind of picture would be that this creature doesn't exist. Still, ResNet with PyTorch outputs an estimation of 23% for tiger shark. Recently it has been shown that learn the majority of oval shape information in the first few epochs of conditioning, and that this information is encoded in the last layers of the weighted networks. It should remind us that weighted networks in general do not have any semantic information encoded. That's their strength and their weakness at the same time. And actually, regarding human perception, I was also struggling with this picture because the tail fin to me looks like a tuna, and not like a shark, because on the internet, this image circulates as a cow shark. But yeah, I thought a cow tuna would be more appropriate. Maybe we can discuss it later on. Let me show the 2 last examples. Eva Novak works, or she is part of a design studio called Noma in Warsaw. She developed this anti-recognition jewelry mask and it reverses the nose-eye relation. And that's what I like about it. One could definitely go out on the streets with that. So this, of course, this project reminds of CV Dazzle, which we all, I think, know from Adam Harvey. It has grown much stronger over the years, so many people have picked up on that. So I won't dig deeper into this. And instead, I want to discuss another project by Harvey. This is megapixels, and megapixel is really important because it shows how to create impact as an artist and activist. Megapixels is a collection of essays about training data, basically faces, that have been extracted without the consent of the depicted persons. There are, for instance, image sets scraped from Flickr or taken from a surveillance camera inside a cafe in San Francisco that goes by the name Brainwash Cafe. Harvey researches those training data sets, publishes about them, with the goal to insert ethical and political questions regarding that training data into the developer circuit. And he does so successfully. Several of these datasets have already been retracted. For instance, the MS Celeb dataset and the Brainwash dataset. And I think Adam needs much more recognition for doing this kind of really strong work. Let me give an outlook at the end of my talk. I think we can trust in the incompleteness of software figurations. So they always are going to be incomplete. And we need to understand that automated pattern recognition is embedded into other software figurations. It doesn't exist by it alone. It's always in some other software application. It's already on our phones, in photo applications, it's in Photoshop. Well, yeah, I'm not gonna mention all the, okay. So, but we need to understand it's embedded. It's always part of something else and something bigger. Only then it begins to make sense. So while complex pattern recognition figurations may appear as semi-autonomous, it is important to stress that they are human-made and human-initiated, and that a lot of labor went into it, which is invisible or which becomes invisible. So this opens the space for understanding it as a human, social, and political relation, which then can lead to intervention as well. And let's reread technology as social relations. Let's question the social relations that encourage a specific extractivist and capitalist framing of pattern recognition. And let's also acknowledge the hype around pattern recognition and about pattern recognition critique. It will surge at some point, but the discussions and the basis of the problem won't go away. So it's also a question of institutionalizing a critical AI discussion and creating impact in the real world beyond demonstrative hacks. Yeah, and I want to finish with quoting Public Enemy, "Don't believe the hype." Yeah, thanks for listening.
Thank you, Francis. I had a little question, because all the examples you give seem quite inaccessible to an average person. I mean, to hack this system today seems quite difficult, and not because it's very asymmetrical, the relationship we have now with those kind of technologies. So do you really think that it's still possible to keep this this working? I mean, if one person can really intervene in this kind of systems?
Yeah, I think the technical intervention is always just the first step before, or to then create a political discussion. That's what we can learn in the project of Paulo Sirio, and we can learn it also in what Adam Harvey does, and I think in many other projects, also in Adversarial IO. And there's one weakness, and the weakness in these figurations of pattern recognition is that you can poison the input data. You can give it, you can pass on input data that makes kind of, or that is outside of the scope of what has been trained. And that will kind of always at least shake the system, and it also will shake the system that is beyond it, because as I argued, it is embedded into other software. So if you manage to trick through data the AI algorithms, then you're also able to trick whatever application is behind it.
But this would need to be done at very huge scale, no? To make this input data poisoning work. I mean, it has to be at a really huge scale, no?
Yeah, well, the project of Simon Weckert, for instance, you could call 100 smartphones huge scale, but it's possible, I would say. It's kind of a more question of the way of thinking about it. Or if you remember this story of this bot called Tay by, I think, Microsoft Research, like a few years ago. So it's also an example of poisoning, because the racist slurs and the anti-feminist offenses that where it was offering after a while, it was trained by those people who were talking with the bot. So they were able to introduce this kind of stuff. And of course, now the engineers have sort of learned that they have to, kind of add filters or something. But yeah, how many filters do you want to add? So there's always kind of a way to playfully, or let's look at the Uber drivers who found out how to play the Uber system to get certain rides, or also there's another story where they were able to connect with each other through the system. So there's always, the system is playable, and even if it is not playable and adversarial attackable on the AI level or on the pattern recognition level, then it might be possible to attack it or to play with it or to manipulate it on another level of that software. And the important goal always is then to initiate public discourse. Yeah.
Maybe I can actually latch on to that question,
Yeah,
if you allow me to, Marie. I think some of these examples, and for instance, I agree with you regarding, new tools for organization, for labor organization, the Uber thing. Amazon workers did something similar. Those are great examples of bringing the issues to light and bringing them into the public discourse. But I think some of the adversarial projects, so to speak, right, including many of the face mask type of adversarial projects, or clothing, or holding up signs, I feel they kind of set a dangerous precedent, because they suggest that this is a design problem, and it's not a design problem, right? Like any design approach attacking these systems will fail. And even, in the technical communities, all of these adversarial techniques only succeed within very, very narrow constraints, right? These are experimental setups, and they're not translatable into the real world. So if I see these projects, on the one hand, of course, they talk about things, which is always good. But then on the other hand, they seem to label them, they seem to mislabel problems which are actually problems of regulation, right? Like, lawmaking, much more than they are problems of design or grassroots interventions. And to me, it seems that, much of the general mentality of these communities, I'm thinking about early attempts to subvert surveillance cameras and so on and so on. I think this mentality and these strategies, they don't work anymore. And there needs to be some reconsideration that needs to happen in these communities, particularly around AI systems. And maybe it's time to, become really political instead of design political, so to speak, and really work on regulation and not on fashion, to be a little bit provocative.
Yeah, it's maybe it isn't even so provocative, because it kind of, you are just pushing more forward than I was doing now in the talk. I was trying to show two pieces. The one piece that I think is like really looking much more deeply into the language that we are using as a way of reflecting on also when developing this critique on what kind of objects we're dealing with. And the other part, when I was stressing that this is always a social relation, then of course that's kind of referring to the point that at some point when you understand it's a social relation, you understand it's political, then you also understand that it needs regulation. And I found it very interesting just recently to read how much the large companies like Google, Facebook, and so on try to change the discourse towards ethics. So they are financially supporting research that goes towards the direction of ethics, which would be something that would be voluntary for those companies. And so I agree with you to really look into the question of regulation. But now, at least when it comes to me, we would need another partner to talk about it, because I'm not qualified to talk about regulation in that sense. So this is kind of not my expertise.
And maybe I had also another question to Fabian. You were talking about using GANs in medical images to see if there are tumors or whatever. And is it also, we are talking about regulation, and is there any discussion or regulation about the use of those technologies in medical imagery, or is it not really considered as a problem?
Yeah, this is a good point. Thank you for that question. I mean, this paper that I'm quoting here, that I'm showing the figure from, is a technical conference paper, right? It's not written by critical AI researchers. It comes from within the technical community. So people are very, very aware of the limitations of these technologies. And I'm not an expert on medical ethics. There are some people working on that. Moritz Kreisner is one of them, for instance. But I'm pretty sure people are aware, but I think the more, let's say, the more pressing issue is that these limitations that I showed are fundamental limitations, right? They do not depend on the area of application. These systems have the same problems when you use them to look at stars as when you use them to look at MRI images or at human faces. So there's something structurally wrong with this approach. And I feel that is the thing that doesn't get considered, like that people don't consider enough, right? That's the part where people stop looking, because it's very easy to pinpoint the obvious flaws. And I mean, in a sense, this image is also one of these obvious flaws, but there's an underlying problem with all of these approaches. And that's the one I try to put forward, which is exactly that, if you use these systems, it looks like you're just enhancing something and keep parts of the original. Like you keep, you're just doing something to an image and then you get a manipulated or an enhanced or a recovered image. But what in fact happens is you pull images from the latent space that have been there before, basically. And you replace the image that you're working with. And it never looks like that is what actually is happening, but it is always happening. That just happens when you're using GANs. And again, I feel this is the part where people stop looking at these issues.
Yeah, because I read also in another article that they use this kind of reconstruction techniques to also by the police when they have only half an image or a very bad angle, whatever, and then they reconstruct like an imaginary enemy. And yeah. But what can happen is that you can be maybe this outcome, when you don't know.
I mean, the police has been at the forefront, really, of naive, stupid, and outright dangerous uses of many, many AI technologies, both in North America and in Europe. But you're absolutely right. People have tried this. And if you combine this with the more recent issue that, in fact, maybe GANs do memorize identities. They do memorize some images. And we have no way of really knowing, because looking at these systems is always empirical work, right? Because this is the whole question of interpretability. You can't just go ahead and, open the black box and there it is. There's the bias, there's the problems. It really is like, probing and pulling these systems. So if it really is true that, some images are memorized, the image of a perpetrator might be completed with, half of your face or something like that. Let's say the terrible and awful and outright dangerous scenarios are really infinite with this technology, because it's so speculative, really in a negative sense, right? Not in the sense of a utopian, this could be, but really in the sense of this is fiction, but it's fiction based on a limited set of facts, right? So this is absolutely a big problem, and I think the more research is done on that, the better. And it requires, I feel this is a topic that goes a little bit beyond the stuff that usually gets passed around in the critical AI community, because it requires like a close reading really of one specific technical system, rather than talking about AI or the network or something like that. So hopefully at some point we'll have something like maybe critical machine learning studies, right? Which is not about AI, but it's really about these very, very specific technical objects that we need to study empirically today.
Yeah, and even when you were answering to Francis also on this tactics and the need maybe to become a little bit more political, but you have all this range of technology, like we were talking about this at the last event with people from Quadrature du Net, etc., and who are working on, who were working with Paolo Cirio on this project to ban facial recognition, and they were supporting this campaign, and we can see that there is the same kind of problem with this facial recognition technology. But as we can see also, is that it's not because it's not working or it has flaws or it has lots of problems that it's not applied, it's not used, which is quite difficult after to stop once it has been, people have get accustomed to it or whatever.
Yeah, and I see this as a particular danger with GANs, because they produce images so readily that then become part of the discourse or the global database of images, or what have you. You put them out there, they're on the internet, and then there they are, and they will stay there, right? So even if you label them as fake and as generated, they will always be around. So whenever you use one of those systems in a bad way or in a questionable way, in a problematic way, you keep adding on top of a pile of questionable material that is out there that will never be smaller, never grow smaller, it will always grow bigger. And then, of course, I don't want to go too far, but then these images get used for the next round of systems, right? They become the training data for another system. So eventually you will not be able to even distinguish between, real and fake images anymore.
Yeah, but this sounds logical in a way, because these faces are all already around, already circulating on the internet, already maybe scrapped by databases, and probably already get labeled by Turkers, and we have this kind of crazy loop.
Actually, I'm complicit almost in that. I showed a new imaginary person today. Usually I show the same person. So in every recording of one of my talks, there's the same imaginary person. I also have it in some blog posts, or there's even digital versions of that. So this imaginary person is here to stay, unfortunately.
Yeah.
Yeah, but an easy measure, Fabian, for you would be to generate this one person and look into how you can generate like different views of this same non-existing person and then consequently label it Fabian Offert, and consequently make sure to put these kind of images online of yourself. So this, it's that's kind of the maybe the subversive mind of what can go on with this stuff as well.
Yeah, I really like that idea of subversive labeling things. That kind of makes sense to me, actually. Yeah, I think that's a good point.
And is there any questions from the public?
I would be very happy to take questions from the public. Also, if you think it's a stupid question, I mean, really, like, if you don't ask us anything, then it's like really boring being here. So please come forward, ask a question, and be sure that Fabian and I mean, we are happy. We have been invited, and so we are very happy to answer any questions. And yeah, of course, there is no stupid question.
I see a question in the chat. Maybe I'll briefly read it. So Estelle asks, hello, thank you for this conference. Is it hopeless to try to fight GANs? Does reality still exist nowadays? Yeah, good question. I wouldn't say it's hopeless, but I think fighting or even coming to terms with these technologies requires, let's say, much more technical engagement than people are usually willing to give at this point. So we desperately need people to learn these things too, right? Like people with a critical mindset to learn to understand how these things work, or even better, for people in the technical communities to start working on these issues.
Yeah, I expect there are going to be law processes in which, on a juridical side, they will start to try to decide on the truthness or truthfulness of GANs and their output. And what I also want to emphasize is that we shouldn't concentrate too much on those images of faces. And I found it very interesting that Fabian and I, we had a lot of examples that were not faces. And I think the current discourse pretty much concentrates on surveillance as something related to the face. While we were both trying to show there are a lot more applications in very different areas, in science, in research, in the automation. So I wasn't, of course, showing examples from production, but I'm sure that in some Amazon delivery centers there are convoluted networks are being used and can be also poisoned. And I think also Fabian can even provide more examples which are not faces. So I think this is kind of a blind spot that we always circle around the question of what our face is in relation to the GANs. And I don't want to dismiss the question. I just want to make aware that we tend to steer the discourse towards this question.
Yeah, I absolutely agree. Actually, that was also part of the point I was trying to make.
There is also a question by Catherine Parker.
Oh yeah, hi Catherine.
Yeah, maybe you can summarize it.
Yeah, should I read it briefly? I'll read it briefly. I'm also conceptually interested in a talk on GANs used for fabricating internal organs, cancers, portions in medical scans. The data sets are based on depth sensing. I think that's right. As they penetrate the edge of what's visible. I was wondering if you could speak more on the theoretical implications of an AI that can generalize an internal condition. That's a great question. I'm not sure if I can answer this appropriately. Let me think. I mean, at least for the neural network, for the machine learning system itself, the kind of image that it learns does not really matter, right? It's basically just 3D matrices. And I think the depth portion of MRI images doesn't play a role in this specific application. So it's basically 2D planes that are processed. But it's certainly super interesting, particularly also because I was talking about the black hole as something that happens at the edge of the visible. Of course, the inside of the body, it's kind of like the opposite boundary, right? The opposite end of the spectrum. Yeah, so it's a good question. What happens if more and more of these boundaries are explored by AI? I have to think about that more. Maybe I can give you a proper answer in class next week, because Catherine is one of my students. And there's also
there is also a question by Inka Ans.
Hi, great to see you here. Thank you for coming, first of all. Can we use GANs to recognize deepfakes? No, we can't. But we can certainly train slightly different architectures, so very basic deep convolutional neural networks, on fake persons, on imaginary people, and try to use them to distinguish between real and fake images. But actually, as much as GANs, these systems would have the problem of basically just knowing the limited set of imaginary people that you give to them. So, the basic problem, the fundamental problem of GANs kind of comes back even in the attempt to recognize deepfakes with these systems.
You have also already startups that are proposing this kind of service. I mean, that send softwares to be able to see if it's a deep fake or not. But then you have another business that is appearing.
Yeah, it's all startups feeding each other with images. There was a great paper, or there is a great paper by Kyle McDonald, the artist, how to spot fake AI generated images. And he had a pretty good guide to spotting, the minor flaws of these imaginary people, but I think it doesn't work anymore, actually. I mean, for this guy right here, I can't for the life of me spot anything wrong with this image, really. I can't. Usually it's the ears, right? Or like the pupil, something like that, but it doesn't work anymore. They've gotten too good.
Yeah, right.
Yeah, let me piggyback on this question a little bit and intervene also a little bit. So I think, again, here it shows that, of course, the question in itself is valid and is important, but at least to machinic systems, the face is not of such an importance. It's more like how do we use websites, where do we click, how can we be identified through a universal click identifier that's being used by Google advertising, not adversarial, but advertising services. So these kind of traces, transactional data is kind of more, at the moment at least, more important to tell about our person than it is the actual face or the image of a face. And the interesting thing is how long will this kind of hierarchy be continued? Will there be a point when the GAN or the image of the face will become more important, or will it be always in that way that our transactional data is more important than, well, whatever person we are presenting?
A last question from our audience. No, very shy audience tonight. Maybe, as you said, it's also a little bit impressive because you need to understand a lot. Here is Christina. Christina Coquior, she asked Francis, I was wondering what your opinion is on whether machine learning can actually aid in producing subjectivities that are not optimized for profit, that are not aiding capitalism, or if you know examples.
Yeah, that would lead now to a very long excursus into what we rethink capitalism is and how it is constituted. And from there, it would be possible to talk about it. I tried to put it in a few sentences, maybe, but it's impossible. So if we go back to the very basic Marxian notion of that capitalism is a society that is organized in a way that it produces goods, and it produces these goods not for the sake of that they are needed and that somebody will use them, but that they can be sold to create profit in the end. So this is a kind of, so the labor that goes into this process is pretty important. So this is where I would situate a little bit this notion of capitalism. And now the question is if ML can actually aid in producing subjectivities that are not optimized for profit. Yeah, no, I would go the other way around. I think that the changes in subjectivities would happen if labor could be organized differently. For instance, if we did not have the division of labor that happens to produce something and labor that is necessary to reproduce ourselves, and that is usually gendered. And then if we're working on that, then whatever technique there is can come in and can change the way we use it, or can be used differently from that perspective. But I think you can't begin with the technology. You have to begin with the political. Yeah. But yeah, maybe yeah, Christina and I, we know each other, and we maybe have to continue this discussion by phone or in some other way, because it's really complicated. But I can already say that I'm writing right now an article, a very long article on exactly these notions of data and Marxian notions of labor. And hopefully this will appear at the end of the year. So I'm working on it, and yeah, maybe then there is a starting point for another discussion to think about data, databases, pattern recognition, and so on. Yeah.
Maybe just to briefly add, you should also, I'm talking to Christina asked the question, you should also check out Matteo Pasquinelli's work, who has written a lot on labor and artificial intelligence and the question of capitalism that gets enshrined into these systems. What can you tell us? Oh, there's a question. Okay, what can you tell us about DALL-E creating images from text? Well, one thing I learned from this is that, the other artist that computer scientists know next to Van Gogh is Dali. Usually they just, put Starry Night everywhere. But to really answer the question, this is an interesting point, because Dali is let's say a new generation of architecture, right? It's a transformer architecture, the one that people originally invented for the large scale language models like GPT-2 or GPT-3. And at least to me, and as far as I know, also for the rest of the critical AI community, this is completely new territory. Partially because much of how these things work, except for the theoretical part, is concealed by OpenAI, right? They don't let you look into GPT-3 at all. So this will become more difficult, actually, to close read than, for instance, GANs where everything you could ever possibly want to see is open source, and you can look into it, right? So I can now, at this point in time, I can read the transformer paper, right? I can look at it, but that does not really help me in a critical analysis of DALL-E, or what's the one, Clip? No, I forgot the other one. But this is a new set of architectures, and this also speaks to the pace, right, of like how fast things are appearing and how difficult it is to catch up with these developments.
Maybe I have a question to Fabian. Fabian, what do you think is the best paper for people who are not so much invested into the whole topic to start reading about it? What would be the author to go for and look for to read more as an introduction?
That's the hardest question I got tonight. I mean, I really like Matteo's work on a lot of these things, and it's also very accessible. Also, I won't name any single author, also the so-called fairness, accountability, and transparency community has a lot of great work on critical readings of artificial intelligence. Yeah, there's much out there, and maybe check out the bibliography we have as part of our allmodels.ai project. That's maybe one way to start. And read my papers too, of course.
Maybe you can share the links also to your publication. I don't know if we can find them on the same website. Is this a question? There is a question about the concept of technological singularity. Do you think we are close to such a concept nowadays? I don't know who wants to answer this one.
My answer will be very short. No,
yes.
We're absolutely not close to this in any way whatsoever. This is never going to happen. And actually, because we're talking about bodies, right? I think this is still one of the biggest obstacles. Even if you wanted to achieve sentient machines and singularity, as long as these machines don't have bodies and are not actors in the world, we will not get to this point. I think. I hope.
Yeah, the concept is actually what I call AI hype. And when I had this section about the embodiment of thinking, it was also an argument that about exactly that there won't be any singularity, as they call it. Yeah.
This is a sad end, no singularity. Okay.
That's another question, I think.
I think we are maybe here. Yeah. Are there ethical implementation of AI when the training set are small, potentially made for and by a small community? Very interesting question. Fabian, you want to answer this one?
Yeah.
Maybe I start.
Yeah, you can do it.
Yeah, the problem with small training sets is that then you get more bias. Whatever you do, you're gonna get a larger bias because the kind of the guessing game is just bigger. So yeah, And also, I already made this argument against ethical and pro-regulation. I think it's not so much a question of ethical, but it's really a question of regulation. And Fabian, please go on.
Yeah, I don't think that's necessarily true, actually. I think there's no relation between training set size and bias, at least in a technical sense. But the question of smaller training sets is a really good one, because it points to, I think at least, to one scenario where some sort of subversion of all this whole development would be possible if you really have models that work with small data sets. You can think about really building your own models that do your own things, and that would maybe at least at some point kind of like break the hegemony of all these ImageNet trained off-the-shelf models. Because one of the biggest problems is that whenever you want to use such a system, most of the things that you will find that are usable, readily available to you, are standard architectures trained on ImageNet, which is this very infamous data set that has all these different classes of everyday objects and a million problems of bias and misrepresentation and all of these things. So if you get to the point where the architectures work better with smaller sets, that's really maybe the point where grassroots tactics will start again to make sense, and I don't think they make sense now at this point.
Yeah, it has been a kind of a disappointment in the recent, like last year, European initiative on data and how they called it data spaces. So they have defined 9 different data spaces, but they were mostly thought as a kind of an industry project. And what was missing was a kind of a civil pattern recognition infrastructure that would be open for citizen science, that would be open for NGOs, especially. Like think of what in Germany, Pro Asyl, or any kind of other non-government organization, Amnesty International, would be able to maybe add, or maybe there has to be founded a kind of an NGO on its own that provides this as a service, or also as a kind of a part of a political discourse. So there's lots of space for developments into these directions. And at least at the moment, as I can see it, unfortunately, the European Union is not picking up on that, or it's not thinking into that direction.
And maybe we take a last question. Do you think we are in the peak of AI? In more detail, will there ever be a way computers will be able to do something that humans never tell them to do?
Yeah, that's the grand old question of artificial intelligence. This is already in Turing's 1950 paper on computing machinery and intelligence. It's one of his main objections one of the main objections that he tries to argue against. He tries to debunk that computers will never be able to create something new, right? And Turing says, people that say that that's not going to happen really don't value the stuff that can happen if you just work out consequences enough, right? If you do number crunching in the most complex way. So I would maybe say yes, but that doesn't mean that we will have sentient machines or conscious machines or anything like that. I think we have to distinguish these as two different questions, right? Like the appearance of machine that can produce something that's interesting or come up with novel ways of doing things is not intrinsically linked to them being intelligent by any means.
Yeah, I think we agree on that. There has been, or there is a great text and article that is available in English and in French, and I'm really was happy to read it by it's by Cardon, Cointet, and Massière from 2018. It's called in English "Neurons Spike Back: The Invention of Inductive Machines and the Artificial Intelligence Controversy." And it details, it's 36 pages or so, but you can read it in chunks. You can really read like 10 pages and then go for the next 10 pages the next day. They really detail out the history of AI research since the 1950s and how there have been different waves and different so-called winters of AI. And from speculations on the future usually can be made like 7 years in advance or so. So you can look like 7 to 10 years in the future and you have like some reasonable idea of what could happen. So anything beyond that is anyway like total imagination. But if we look into the past then we can see that there have been waves of this AI development, and we can expect at least that there are gonna be also waves, and we are riding on such a wave at the moment, and most likely there's going to be a winter in a certain way, because at some point we will, that's also in relation to the AI hype. The AI hype sets the expectations so high that even many of those people who are doing the research, not necessarily the people in the industry, but in academic research, they are kind of afraid of the next AI winter when we are going to realize that these and these and these and these ideas just didn't realize, and then funding is being cut again from them. And this happened already like 2 times over in the past, and yeah, it may happen again. And thanks to the person who posted the link. I think it's an excellent paper to read it.
And there is a very, very last one from Inke Hans about could there be something like outsider AR art as being art by self-taught or naive art makers?
This is a fantastic question. So I would say yes, but we don't have that yet, because I think we need to distinguish between really like outsider art in the sense that you're defining it, and people using this technology in not very complex ways. Because most of the AI art that I'm seeing right now and that keeps on appearing, some of it is is aesthetically interesting, but technologically it's basically almost like using examples for how certain systems work. It hasn't become complex enough. That being said, I think there's great precedents for outsider digital art. One is this one, Tempo OS, which is a whole operating system that has a biblical theme. So every technical component has a biblical meaning assigned to it, and the whole operating system, very, very low-level programming, is based on this like kind of like idiosyncratic approach. So I'm waiting for this in AI terms to appear. But yeah, I think it's definitely a great concept to look at. Absolutely.
Yeah, the question is a little bit outside to what? Yeah, is it like is outsider AI art? Is that outside of humanity? Then it's clear. Then we can say no. Outsider AI art will not exist, because it's always humans who kind of set these things in motions with, or it's data that is based on human subjectivity. Yeah, if you wanted to have an outside of humanity, it would need training data that is not related to humans. That's maybe possible. So you could maybe look at weather data or at whatever organic things happen in our atmosphere, or to physical aspects. But already the decision which of these aspects to choose to base your training data on is already a human decision, and also the decision to place it in the context of art. So I think as fascinating as the term is, I can't see the outside of humanity, of the outsider art, outsider AI art.
Yeah, I think the conversation will go on next week, because at Gaîté Lyrique there will be another meeting with around ethics and AI with the researcher Anna Jobin and the artist Paolo Cirio. And this will be in during the seminar of Antonio Casilli, called Étudier les cultures du numérique. So you can join us again next week. And thanks a lot, Francis, for the talk. Thank you, Fabian, and hope to meet in flesh at some point.
I hope so too. Thank you so much for the invitation.
Thank also for the participation to our audience. And see you soon.
Yeah, bye-bye.
Thank you.
Bye.